So this is our discipline-specific presentations. We have 3 faculty who are going to talk about how they use LibreTexts in their discipline.
Now you can hear me, right? So yeah, I teach math, and I've been overseeing a lot of work on, some of the work anyway, on the math library. And so I can share some of what I've done with the LibreTexts books that I've been using in my classes. I think I've converted every one of my classes to use a LibreText at this point. And that includes basic algebra, intermediate algebra, calculus 1, 2, and 3, and differential equations. In differential equations, I still have, I think, one of the 3 texts I use is a LibreText now. It's the Trench book. But the books that I've done the most work with have been the calculus 1 and 3, and probably calculus 2 somewhat. But the others I've gotten in place, and so worked a lot to get them to present well as best I can, and have another layer, I guess, of work to be done to try to customize them to what I want them to really to look like. So let me actually show or share my screen here, and looks like I have that option here, and show a few things. So I guess first of all, this is the Monroe Community College area in the Math LibreTexts courses. And so we've got the basic algebra, intermediate algebra courses that I've worked on. I've got a colleague or two actually working on college algebra and pre-calculus LibreText. So it's great to have some colleagues excited. I've got a colleague who developed a calculus 1 a couple years ago, a LibreText, and I've actually gone and been working independently because I'm working with a source OpenStax book that I'm pulling most of the content from and editing that, fixing any typos I find and trying to improve the formatting, and then creating my own version of that for Calc 1 honors. And then I've got a Calc 2 LibreText that I created the image for here, Calc 3, and differential equations, again, the ones that I've been using. And another colleague who's developed a LibreText for discrete math, again, customizing material that's out there and adding some of her own. So this is, again, just the books that we've made use of here at my college. So if I look at, say, the Calculus 1 book that I'm using, it's great to be able to use LibreText to customize a book. It's like the best of both worlds in that I get to use material that's already there and already works really well for a lot of the topics I teach. And then I get to add my own material where it needs to be added and where I want it to be added, and even to tweak sections that were already there to make them say more what I want them to say. And again, I guess I've done the first pass, which is to get everything in the right places. So for Calc 1, I've got my functions and graphs material for reference. I've got limits that have exercise sets right with them. I've got, let's see, derivatives. I've got applications of derivatives, integration, and appendices. This is all my own versions of pages that are out there in the bookshelves. And so I've been able to just make them lay out the way I want them to, reorder things. In fact, the limits chapter I reordered quite a bit from what the OpenStax had, including some different material from limits at infinity there where I wanted them versus having it later in chapter 4. And anyways, I've added my own exercises for some of those sections. Been a lot of fun to do. Let's see, in the derivatives, applications of derivatives chapter, which is where I've been working most recently, I put in the parametric equations material from, I think, chapter 11 in OpenStax. Was able to put them right in here, and then again add a little bit of material of my own. I think it's in this section here, dealing with speed along a parametric curve. So I was able to put my own material integrated right in with the rest of the material on the page. It looks like it's part of the section and lays out nicely. And I can even add my own examples, my own images, and again, have material that my students can use that I had just given them in my notes before, but now it's here in the book as well. And I guess I haven't had as much experience with this because this is what I'm teaching right now. So I'll find out what my students have to say about it. But my Calculus 3, in that class, I've added bit of material in a couple of sections in that book already. And those sections really have reduced the number of questions I've had from students on the types of problems that weren't in our book before, and that now I've included some specific examples for. So it's really been a lot of fun to have that ability to add my own material, my own examples, customizing open material in a really easy way. So LibreTexts has made that so much easier than anywhere else that I've tried, and it's been a lot of fun. Let me see here. So in Calculus 2 and 3, I've been able to integrate some, I guess that's a funny word to use there because integration means something else there, but I've been able to add in some dynamic figures to illustrate certain things using using CalcPlot 3D, which is a tool that I've created to help visualize mostly multivariable calculus, but it also produces visuals for volumes of revolution and some differential equations topics, and even some parametric equation stuff. So in this section on volumes by slicing for Calc 2, I've been able to add some dynamic versions of some figures that were there before. I'm getting to one here. This one has a dynamic version here that you can actually control, or the student can control, and actually generate the solid of revolution. We can show a representative rectangle and move that representative rectangle through the region. We can rotate that or revolve that rectangle around the axis. In this case, it's around the x-axis. Rotate that a little bit over here in 3D. There's even a way to use 3D glasses with it, but anyways, that's beyond this demonstration. But you can also show washers, and in this case, indicate the number of washers or increase the number of washers. You can rotate those around too and see what the washers would look like. That's part of what's being covered in this section. So it helps to illustrate what we're really trying to help students see as they are learning this topic. So this one, again, revolved around the x-axis, gives actually the volume of those washers there. Let me go further down on the page, if it's gonna let me there. The last example, there's 4 of them that actually have these built-in dynamic visualization components to them. Here's a third. The 4th one, I added in the ability for changing the axis of revolution. So here we can change the axis. Right now it's y = -2. So if I rotate around that, I get this 3D slice. We could change that to be y = maybe +5. Should go up above. Okay, you can rotate it down to see the view there. We could make it x = +5, which would rotate this triangle around the x = 5 vertical line. And again, we could rotate that all the way around if we wanted to and see what that solid of revolution looks like. And again, this is just hard-coded, I guess, examples from the book that I'm able to then make a dynamic visualization for the students to play with or for me to use in class as a demonstration tool. Now, CalcPlot 3D itself can be used independently to look at any of these images as well. And you can create, with a little bit of work and some instructions, your own dynamic figures like this to put into the LibreTexts textbook. Now, with that said, let me jump to Calc 3. This is the first LibreText I have worked on. And so I've done a little bit more here and there as a second pass to modify it. I've added my own images for, looks like all the chapters to indicate things from, mostly from CalcPlot 3D or from another tool that I created for visualizing vector fields. Actually, that one is still CalcPlot 3D as well. So in this book, there's a section actually I've added of my own. So 13.7 on Taylor polynomials of functions of 2 variables. And the fun thing about this was it was material that had been in my notes to supplement my textbook in the past, but now I'm able to make it look like it's part of the book and integrate my examples or add my examples in. And as you go, you can see I've got some dynamic figures built into this particular section that can be rotated. Got the tangent plane, 1st degree Taylor polynomial. And then if I go further down on the page, oops, rotating Here's the second degree quadratic approximation to the surface. So it has the same concavity as well as the same slope at the point of tangency. And then further down on this set of notes, in addition to another example, I show higher degree Taylor polynomials. And this was something that I developed in my own sort of playing with this concept, and always sort of wanted a place that I could sort of publish it in a sort of sharing, this is what I've come up with idea. And I've actually been able to share it with my students, develop some exercises for it, and had students actually present their own little video in my online class using this more general nth degree Taylor polynomial formula. So it's sort of fun to see the students begin to engage with the material as well. So I did some exercises for this section of my own. And the neat thing about this, you can put, the credit for what you've added to the book and give credit to who you're getting the book from, the OpenStax book in this case, for the original source for most of it. But this whole section was my own. So I was able to add it into the book, customizing it to look exactly the way I wanted it to. Let's see, any questions so far? Guess the chat I don't have visible, but I see there's some things on there. See some people have maybe answered for me. I don't know. Yeah.
There is a link to your books.
Yeah.
I haven't seen any questions.
Any questions? Okay, just a bunch of links there. All right. One thing I wanted to mention is I've found ways of helping students to engage with my book, to begin to read the book more. And it's sort of ironic, but when I ask them to find typos, it turns out that has helped students find typos, but actually really engage with the book. I tell them they're going to get some extra credit if they find anything that may need correcting. And so I found a number of typos, and of course it's progressively getting harder to find those. But even exercises in the book where they're practicing as they review, and then finding some of the solutions that might not have been correct. And so getting those fixed, but having students really engaging more with the book because they're able to find those and get extra credit. Let's see, I wanted to actually show another section in Calc 3. This one is one I added a number of 3D images to. This is one of my favorite, actually, which was a static image in the book before. It looked a lot like this. And now this line in space that it's hard to tell it was in space when it was just on a flat image, either on the paper or on the screen even. Now you can grab it and rotate it and begin to see that, oh, wow, that really does sort of look 3D. Okay, you can see that the vector, the direction vector that's red there, is parallel to that line, and it really begins to become a little bit more convincing that it's a three-dimensional line. So that was something I was excited about being able to show. Further down in this section, sorry, it's probably spinning by here. There's another one. There's actually a number of them in this page. Here are skew lines. The original image looked a lot like this, the original figure, but now you can actually get a better, more convincing view that these really are skew to each other. They're not actually intersecting each other, even if they were extended. Get the idea more clearly across. And then further down is the first image that I created CalcPlot 3D image for. It was actually inaccurate in the book before. It had two planes on top of each other. One was transparent, but they weren't really intersecting. And so in this case, I was able to make it look like they truly intersect, and you can actually rotate it and see what they look like. So again, just really neat to be able to take the three-dimensional concepts in this course and create figures that are really 3D. You can actually involve yourself in them more deeply. I guess that's a pun, but the other thing you can do with them is use 3D glasses. If you click on it, and I think Control 3, even just typing the 3 key once you've clicked on it will turn 3D glasses mode on and off. So if you happen to have red, blue 3D glasses, you can try them out on one of the figures in this book or the other book. So let's see, the other books that I've developed, or actually other content that I developed in this book was in chapter 12. And I was just looking at that in 12.1 in particular. I was able to add a number of subsections. I mentioned this earlier that students had had trouble with this concept before I added this to my book, but because I was able to add this in here, the idea of parameterizing a piecewise path was one of them. So if I click on that, I added this still image in here from CalcPlot 3D and was able to figured in this case that was all that was needed here to get the image to be helpful for the students. Sometimes dynamic is not required, but here I was able to add this example and a number of examples around this or topics around this to help them learn how to do something that I had just taught them in my notes before. And here I was able to add some more, I guess, detailed writing, more formal writing to help them see how to do the process of parameterizing a piecewise path around a region like this. And again, since I've been able to post this, my students have found it to be easier to learn and have asked fewer questions and have done better on the corresponding assessments on these type of problems. So let's see if I had other things listed here. I know that the last speaker had said he uses LibreText in his LMS, and I have not done that. I've not chosen yet to do that. So I use Blackboard with my classes, but I found it nice just to link to LibreText, have it open in a different tab, and be able to work with it as its own entity so far. And, you know, I guess I could show the ease with which I edit, but I think you guys have probably already talked about that in some of the other presentations. Okay, so any questions at this point?
Everyone's very subdued today. Are you the only one that's using these, Paul? Or I know you have colleagues that are working on some other ones, but do you know if people have adopted your?
Well, I've been told, well, I've shared my book with several people that I've met at different math conferences. And even those that I've worked with in LibreText mini courses at the joint math meetings, I'd shared my book with them. So they've customized it. I don't know how much they've used it yet. I've not been in contact to double check where they're at, but I suppose that could be pretty easily followed up with just to see. But I've been able to demonstrate, you know, the books that I've customized to a number of different people. And I know, actually, I know that some people at my college have been, some of the adjuncts even have been using our customized version of Calc 2 and the Calc 1 previous version of it that my colleague had created. So, you know, that much I know. I think another one of my colleagues has been using the Calc 3 book that I use. So, you know, again, I know that they're being used. It's harder to, you know, they don't have to ask in order to use them. So people could be using them in more places than I'm aware.
We can track that sort of thing, can't we, Delmar? Or
Hey,
no?
Give me 20 seconds. I'm almost done. I started when you asked about it.
I figured it was probably possible.
I honestly, so English major, I didn't understand a word you said. So I'm the person to ask questions about your content, which is why I'm hoping somebody else will jump in and ask some questions. I see Delmar's pulling up some of your.
Yeah, and I can do it for specific books if you want, but this is for all of Monroe Community College. So it's at somewhere in the order of 35,000 hits per week.
Wow.
Page views per week. So it did this growth. Here's the COVID bump that we got, and then we've seen across our whole site about a 100% increase in traffic in the last couple of months, and clearly even in Monroe Community College it's about a threefold increase.
Mm-hmm.
But if you tell me what your book number is, I can tell you specifically which one. Like 211.
Yeah, 211 and 212 and 210 are all books that I've been working on, but I know I looked at this the other day, and the 155 was just a shell. So I actually closed that one off from public view because the teacher who started working on it, I think, has gone with another venue or another way of presenting their material. So
Yeah, so for 211, you have about a third of a million page views since you started a couple of years ago.
wow.
Can I
do traffic and such?
Yeah, we've discussed this before, but when you have to do your annual report or your promotion file, having this data available is a reasonably strong argument to put in it. It also advertises the school. So somebody who uses Paul's book and is in the local area may say, hey, I could learn some real math at Monroe. Okay.
They can.
Yeah, along the lines of promotions and tenure, it's oftentimes difficult for individuals on those committees in order to evaluate activities that are online for a variety of reasons. But being able to spit out your book as a physical copy and then submit that physical copy in your packet oftentimes carries a bit more weight, because it's difficult to find out, identify if a website consists of 20 pages or 300 pages easily. But having it physical is one way in order to get that across.
So are there any other questions from anybody about the math content or the way I edit it? I mean, I could even edit the page and show what I do for some of them, but again, I don't know whether that's a need or not. I've been working, while you think, I've been working a lot on the Calc 1 to format the math to make it look nicer, to make the, I guess, fractions that are inside parentheses, to have the parentheses get big enough to actually and contain the fraction. For example, they have the equations that go over multiple lines, actually use the align feature and actually line up the equal signs. So a number of things that had not been fully done before, but make the book look a lot nicer in the online format and in the print format when that's done.
I mean, I'm sure that it would be useful for people to see the editing process.
Okay. Let's see here. I'll share the screen again. So let's see this one. If I edit this page, so if I go to the top, I have to sign in first on this computer. I was editing something a few minutes ago before my presentation on my other computer. But if I go into this one, I can edit. And this page, I think, is all, it's been, what's it called? Forked, I guess, from the original source. So I can now change it however I'd like. I have really further down this page is where I added my own content. I added a new version of an image to this page, although this I think is in the source as well, because the image wasn't accurate before, as was this one, a new one I added from CalcPlot 3D, and that one. So you can see the LaTeX that's used, and again, many of you may be familiar with the LaTeX that is used to create the math. We've customized a few things to make arrows over the, or harpoons over the vector content. There's a couple different ways of creating vectors over letters to make them look like vectors. So I think just VEC is a little arrow. VECS gives a little harpoon, which is basically just goes across and up one way. And that was the way I wanted it to look. So I was able to add those in here. Put little hats over the I's and J's, if you're familiar with that, for vectors. And then let's see, further down here, these are some of the work that I've just done today. I actually added in the no numbers, so I wouldn't have equation numbers on the end of some of these, which, because they're in display math notation with a slash square brackets, they had been coming up with the automatic numbering of equations. So I added those in just a little bit before this presentation, actually. Here is how I made the parentheses go around the fraction. Here's that frac inside here, and it uses this slash left in front of the left parenthesis and the slash right in front of the, or escape right in front of the right parenthesis. And that ends up sizing the parentheses to what's inside the parentheses between them. So that ends up making it look a bit nicer, as I'll show you in a second here.
Can I interject
go ahead.
something quickly, just for a general context? So the source material that Paul used here is predominantly the OpenStax calculus book, which is really a version of the staying calculus book that OpenStax purchased and then polished up. But what if you were to download the code for OpenStax, their equations are all in what's referred to as MathML, which is a different structure than LaTeX that you have here. If you haven't interacted with MathML, it's an exceedingly painful infrastructure in order to use and customize. So a lot of the effort that we've done in bringing in the OpenStax books, besides cleaning things up and fixing mistakes here and there, is to also convert all the equations from MathML into LaTeX, so that you can go in and you can edit it just like what's on the screen right now to suit what you want and customize it. And that's one of the true powers of bringing things together in a centralized infrastructure. And such. If you're unfamiliar again with MathML, you can certainly do a search off of that, but it requires a lot of love in order to be able to use effectively. So it's not a very good end user format for doing things. So.
Yes, this is definitely very conducive to writing mathematics. And for me, the LaTeX I already knew from, in my case, from using it with web work to do problem sets and online homework with my students. So it was a very natural transition, makes it very easy to generate nice looking mathematics. So if we save this page, we can look at how these left and right parentheses look on this and see what it generated. So let's see if I come down. Sorry, it's going to take a second to render. This may not be the exact same place, but you can see these parentheses are around the fractions and they are big enough to encompass the whole fraction. That's the idea of what happens with the left and right. Instead of them being little tiny things that would only be a normal parenthesis height on either side. So it looks a lot better, especially with the exponents, than if the parenthesis and exponent were down in the middle of this fraction. So you can see the harpoon over the R here, making that vector notation. It's also bolding it as well, that escape VEC vex, S for single. There's a vec D as well that gives a double, like a PQ or some other vector with two letters format. You can see the little hat over the I and the J. It also, I'm able to, with the coding there, make it bold as well, make it look like the standard unit normal vectors that are used here, the standard unit vectors that are used here. So anyway, it's been a lot of work to make this math look nice. And I think this is the one we were looking at earlier with the code. Trig, you have to often add the escape before in order to make it look correct as well. So that's something that I've had to edit a lot. Here's a latent number that I want to get rid of. So again, shouldn't really have a number there unless it's a special equation. So I'd usually put the no number with it to make it not have that. Let's see if I could find one that lines them up, because that is a common issue. Here's one. So you can see these two equations have an equal sign and then another equal below and another equal below that. This uses the begin align, end align structure in LaTeX. And it without this, it's really hard to make these line up. So your second line might have the equal sign way over here, especially if it's centered. And then this equal sign might be way back over here. And so they wouldn't really be lining up and looking so nice as these do. I've also added the left and right commands in front of the brackets here to make these bigger. I might even used other commands like the big command to make them bigger. It depends on what's involved. I think possibly that's what I did here. Okay, so again, just different things I've done to try to make the math look prettier. Really, if you're interested and want to know any tips, there are some pages here, reference pages that you can use, and I've edited some to do that, and I'd be glad to answer questions about the way I've tried to do things as well. Okay, any other questions? Guess I could show what else I've got, what other books I'm using here. Let's see. This one is all my books. Let's see. So intermediate algebra, I'm using this year. This one is OpenStax intermediate algebra. I've not done a lot to it other than format it to make it look nicer. I included the chapters and sections I wanted. So right now we're talking about roots and radicals in my course, and each of them has an exercise set associated with it as a separate page, a sub-page. I think right now we're dividing radicals. So if I go into that section, it loads, has table of contents that can jump to different subsections, goes through, the examples like a normal book would, and then crosses things out. This is sort of cool LaTeX to cross things out, and so on. So again, just a series of examples. These I'd probably make larger. It's one of those things that as I'm giving a presentation, I see something that might need to be edited. I usually like to make these display fractions. So using a dfrac instead of a normal frac on these to make them bigger. In fact, I could even do that edit right now to show what I do. So I edit the page. This one is not one that I can edit directly. Sorry, I'm in my transposed version or reuse version. That's actually a technique that's generally used when you customize a book. You first remix the book from the bookshelf, and it comes over as a series of links to the original source, but with your page or section numbers. And that will incorporate even to the figure numbers and so forth. It's really nice. You guys have probably seen that already. But what I need to do is get to the OpenStax version if I want to edit it. And that's where I'd want to go. It looks like section 8.3 or 8.6, whoops, over here that I want to get to. So I don't know if it's worth my while to do that right now. Depends on what you guys want to see. So
you can probably skip it.
yeah.
I may ask, I mean, your CalcPlot 3D is an exceedingly powerful tool that people have access to. Do you think you might be able to do a quick overview of those resources that OER adopters, constructors have access to thanks to your infrastructure?
Yeah, I mean, I guess right now these have two images that I just showed earlier, pages that I just created. But let me put up a new page here with CalcPlot 3 in it. So CalcPlot 3D, it's a visualization tool that has been developed with NSF funds and was focused initially at multivariable calculus visualization, but has been used in chemistry and physics and engineering and a number of other courses as well. I've even had a person contact me saying that they used it to create 3D printed chemistry orbitals structures. So stuff that was a little bit beyond my understanding in terms of the work that I've done, but they were able to use this app to create those visualizations. And you can 3D print actually from the file menu, create an STL file from a plot. So that's something even beyond what you would be importing into LibreTexts, unless you're going to make an image of it and put it in there, which is possible. But what you can do is find an image, maybe a rotatable figure that you want, especially if you've got, in my case, multivariable calculus in mind. But if you want to use a volume of revolution, there's an option at the very bottom for a surface of revolution. You could create one of those to import into a book or put on a web page. And so what you do once you get graphed what you want, you've got what labels and other things you want on the plot and the view that you want to have for the dynamic figure or image that you want to have. You can come up here and under the file menu, you can encode the view to URL. And the cool thing about this is it will give you the ability to actually copy this link and send it to a student or post it in a web page or have students. And this was something that was generated by a colleague of mine for a presentation earlier today on web work and using web work, was have the students actually generate an answer in CalcPlot 3D, use this save to URL feature, and then take this code here and paste it into web work as their answer in a open-ended answer, open-ended question there. And then as a teacher, I could click on it and see whether they've rendered what they were supposed to in the problem in Calcplot 3D. So again, it's pretty flexible in terms of the uses that can be made of it. But this URL can also be used to embed the figure in the textbook, in the LibreText. And it requires a little bit of other work to find that other little bit of code. Of course, there's templates in Calcplot or in LibreText that I could share with you, but there's also a help manual that's right here in the file menu, actually in the main menu. Help menu is the second option. And in that help manual, created using something else here, but it allows you to, the bottom of this gives you instructions on dynamic figures, either with no controls or with some controls. So there are the volume of revolution, for example, that you have controls. A lot of my figures, they don't have any controls. They're just three-dimensional figures that you can rotate like this, embed in the book. So this is giving you instructions on how that can be done using either LibreText or other URL, other web pages, put it that way. So it's not just LibreText that can benefit from this, but it's possible, as I showed earlier, to put these right into LibreText. And the Calcplot 3D version that's being used for these is actually housed on LibreText server, right? Server that's owned by LibreText, so it's right there, and among other materials that may be up there. And it's got my own prefix here, C3D. But anyways, that's where that thing is located. It uses a slightly different prefix in order to have this load as a dynamic figure, by the way. It uses, let's see, this is the standard one. So down here, okay, it has this dynamic figure extra piece in this path that actually loads a different base HTML file. And that makes it hide a number of the controls that would normally be there in Calcplot 3D. And so you only see the figure part instead of all the other information. So instead of seeing the whole Calcplot 3D that we have here, you just see the 3D rotatable part. And then there's the with controls version that allows you to have sliders and other things over here that allow you to vary things and see what happens in the picture. Okay, a lot more I could show, but I know the time is somewhat limited. Depends on what people want to see. So any other questions?
Can you put your contact info in the chat? Yeah. Call in case people want to.
Absolutely.
In case at 3 a.m. they have a question they forgot to ask.